Olá, pessoal, tudo bem? Sejam bem-vindos ao nosso evento hoje. Espero que todos estejam bem. Meu nome é Luciano Pimenta, eu sou arquiteto global de apoio ao sucesso de clientes na Software AG. Hoje, nossa apresentação é relativa a um assunto super interessante: rehosting para Linux com virtualização e nuvem. Quem vai introduzir esse assunto é o Marcus Roser, que é vice-presidente sênior para arquiteturas Adabas Natural na Software AG da Alemanha. Bem, antes disso eu gostaria de contextualizar um pouco para vocês o tópico, né? Antes da apresentação do Marcos. Esse slide ele resume as plataformas, né, de infraestruturas aonde nossos clientes Adabas Natural executam as aplicações, né? Então a gente tem aqui desde os mainframes legados, né, Unix legado, e também os mainframes IBM com ZOS e ambientes Linux, né? Então, essas setinhas, essas comunicações aqui permitem visualizar as opções, né, que o cliente tem para movimentar essa carga de trabalho da base Natural entre essas plataformas. O foco Software AG para a inovação nos últimos anos, né, foi definido como sendo o ZOS, né, mainframe IBM com ZOS, e Linux em plataforma Intel x86. Então, clientes que estão nesses ambientes legados, mainframe ou legado Unix, né? Legado Unix, aqui a gente está falando aí de AIX, Solaris, HPUX, né? Em legado mainframe, a gente está falando aqui de ZVSE, por exemplo, e IBS 2000, né? Que é um sistema que não é muito utilizado aqui nas Américas, mas bastante utilizado, por exemplo, na Europa. Tá? Então, recomendação para esses clientes do ambiente de ambientes legados é fazer essa movimentação, esse processo de rehosting, né? Ou para ambiente mainframe com ZOS ou para ambiente Linux, né? Todas essas possibilidades aí são possíveis, né? E uma vez estando aí nesse mundo Linux ou IBM ZOS, né? Caminho natural, se for a estratégia do cliente, é poder também transicionar essas aplicações para um ambiente de nuvem híbrida, né? Como, por exemplo, utilizando Azure ou AWS, né? Estando em Linux, a maneira mais simples e rápida de fazer essa transição do ambiente on-premise para o ambiente de nuvem é o que a gente chama de lift and shift. Mas, enfim, essa é uma visão global de plataformas, né, de estratégia de plataformas, né? E, enfim, o Adabas Natural acompanha qualquer que seja a estratégia do cliente, né? Nós somos flexíveis e a carga de trabalho pode rodar em cada uma dessas plataformas. Bem, mas o Marcos vai fazer as suas considerações aí sobre aspectos de arquitetura, né, com foco especificamente em Linux e em duas tendências muito fortes, né, que é justamente usar virtualização e usar nuvem, tá? E eu queria fazer um convite, um comentário, né? Após essa nossa apresentação de agora, do Marcos, a gente tem na sequência, a próxima apresentação, eu diria, está logicamente conectada a essa, né? É a Adabas Natural na nuvem com AWS e Azure, tá? Ela vai ser bem prática, né? Demonstrações sobre esse ambiente de nuvem. Então, faço essa ressalva e esse convite para vocês também assistirem à próxima apresentação. Ok? Então, muito obrigado. E agora, o palco é do Marcus Roser e eu espero ver vocês em breve. Tchau, tchau.
So now let's start with the presentation. As you probably know, we launched our Adabas Natural 2050 Plus initiative in 2016, so 4 years ago, to offer customers stability and innovation in the long run. One focus of this initiative is the support of modern and future-ready IT platforms such as IBM ZOS and Linux. On these platforms, we continuously support new market trends and provide innovations based on the feedback that we got from our customer base. In this presentation, I will talk about some architecture considerations with a focus on Linux and two trends, virtualization and cloud. The journey towards the cloud and modern virtualization technologies starts with an Adabas Natural application, which is prepared to run on x86 commodity hardware and preferable on Linux. For Adabas Natural, we support Red Hat, SUSE, and CentOS. If your Adabas Natural applications are running on a different operating system, for example, HPUX, Solaris, or AIX, a rehosting is required to make them Linux ready. But why should you consider a rehosting to Linux? What makes the cloud attractive? What are the benefits? Let's first start with rehosting to Linux. First, you can replace expensive hardware and operating systems with less expensive commodity hardware and open source to save cost. Second, this frees budget for application modernization. The move to Linux is an enabler for modern architectures and reduces the vendor lock-in. You gain the choice to run your applications on-premise or in the cloud, and it's easier to find skilled people. What makes the cloud attractive? Again, it's cost. No capital expenses of buying hard-end software and for managing the infrastructure. Second, speed. Computing services are provided as self-service on demand in minutes with just a few mouse clicks. So that means provisioning a new virtual machine in the cloud takes probably 5 minutes. Compared to the current process of purchasing hardware, installing software, this is a real improvement. You can do things in seconds or minutes instead of days or weeks. Scalability and performance. Computing hardware is regularly upgraded to the latest generation. According to analysts, hyperscalers run more than 30% of their infrastructure newer than 18 months. And last but not least, disaster recovery and business continuity becomes easier and less expensive. We talked about the benefits first. Now let's move into the architecture topic. So we ask customers to find out which system architecture they prefer to run their Adabas Natural applications on Linux. A typical pattern is the following. A storage area network is used for data availability and durability. SAN-based replication to a second site for disaster recovery, either synchronously or asynchronously, depending on the RPA requirements. A x86-based hardware cluster is used for computing power, and on top of that, hypervisor-based virtualization with virtual machines with one of the supported Linux distributions. So either Red Hat, SUSE, or CentOS. A common way to run Adabas Natural in those environments in production is the single instant architecture. I think that this pattern is coming from the days where these applications ran on the mainframe, and during rehosting, customers have applied the same architecture pattern. In this architecture, the Adabas Natural platform and the applications are deployed to a single virtual machine. This includes the database, the natural batch processing, the NTIRX-based natural services, as well as the natural online part. However, if you have scalability requirements or you are looking for higher availability, the following architecture might help you to achieve this. This is a distributed architecture. In this distributed architecture, the application components are distributed across several virtual machines. Please have a look at the picture on the right. In this example, the database and the batch processing is running in one virtual machine. The natural online processing in another one, separated from the NTRX-based natural services. In such an architecture, you are able to run multiple replicas for natural online and natural service behind a load balancer, which gives you better scalability and higher availability. The left picture on the slide is illustrating this. Let's take a closer look at this architecture example. On the top left, you see the end user workstations accessing the natural online application via an AppNX web terminal emulation. 3 replicas are running for scalability and availability reasons. On the top right, you see mobile applications, web portals, and external parties accessing the natural services part of the application through NTRX APIs. Again, 3 virtual machine instances, this time equipped with NTRX and natural. A load balancer on top is distributing incoming requests to the available natural online or natural services instances. Both natural online and natural services are accessing Adabas, which is running on another virtual machine instance via TCP/IP. In this example, the batch processing is running close to the database. That's natural because it makes heavy use of Adabas. As stated already, we are continuously providing innovation for the Linux platform. In 2018, for example, we introduced the Adabas TCP/IP interface to simplify the access to the database in a distributed architecture. Adabas TCP/IP is a point-to-point solution, easy to configure, easy to use, and capable to serve thousands of sessions in parallel. We are currently working on another innovation, and that's a master-slave cluster solution to provide high availability capabilities for Adabas on Linux. We plan to release a first version of the product this year. Let's move to another important topic, and that's how to protect sensitive data. To fulfill compliance standards, our customers are looking for ways to protect the sensitive data. There are several places in the architecture where sensitive data must be encrypted to meet this requirement. The key symbols on the left side of the slide indicate these places. When the data is sent from one component to another through the network, so to speak, while the data is in flight, you can see some examples on the top left, from the end user browser to AppLinks. On the top right, from the web application to NTRX. And in the middle and bottom, from natural to Adabas. or when the data is persisted, so to speak, while the data is at rest. Our ANN products support encryption to protect data in flight. And with the release of Adabas encryption for Linux, which is planned for October this year, the data can also be encrypted when it is stored on disk. So we use industry standards to encrypt the data, not only if it's going back and forth to the database, but we are also using standards when the data is stored on the persistence layer. One important trend in the IT market is cloud native. Cloud native applications are built as a set of microservices that run in containers, orchestrated in Kubernetes, and managed and deployed using DevOps. The advantage of using containers is the ability to package all software needed to execute it in one executable package. The container runs in a virtualized environment, and this isolates the contained application from its environment. A lot of new terms here: container, Kubernetes. So let's answer the question, what is a container? So it's a lightweight, standalone, executable package of software that includes everything needed to run it. Containers have several advantages. First, containers isolate applications and platform components from each other, making a complex environment manageable. Second, containers isolate applications from the underlying infrastructure, giving you the choice to change your infrastructure very easily. Here in this example, you see 3 container instances, one for Adabas, one for Natural, and one for NTRX. The code, runtime, system tools, system libraries, and settings are contained in each instance of this container. Yeah, so for example, a small version of the operating system. In this example, it's CentOS. A third advantage of a container is the following. There is no need to install your platform or your applications any longer. Simply start your container, and if the container image or the new version of the container image is not present on the node, it is automatically pulled from a private or public registry. So private is within your IT, and a public registry is, for example, the Docker Hub. That sounds great, isn't it? You can use DevOps principle, and that's the fourth advantage, to build and test your container images and push them in the registry. This enables you to automatically build and test your applications as well as your Adabas Natural platform components, such as Adabas Natural NTRX, AppLinks, and Connex. All the assets that you need to build the container images are delivered in a Docker folder as part of our master installation. So you can use the installer and the update manager to maintain this master installation, and afterwards you can use the scripts and the assets to build your container images. You can imagine that this can be automated in a continuous integration process, followed by a continuous testing step where you are testing your applications together with a new product version or with a product fix. That's really great. So next question, What is Kubernetes? Why do I need Kubernetes? And what can it do for me? So first, Kubernetes is a production-grade container orchestration for automating deployments, scaling, and management of containerized applications. As business applications span multiple containers, which are running on multiple nodes in your data center, this capability is definitely important. Several distributions of Kubernetes are available, such as the open source version of Kubernetes, Kubernetes as part of Red Hat OpenShift, or as part of SUSE CaaS platform, or as managed Kubernetes in the Azure or AWS cloud, for example. So Kubernetes is giving you the freedom to take advantage of on-premise, hybrid, or public cloud infrastructure, letting you move workloads very easily. Just provision and deploy your containers in an instance which is either running on-premise or in one of the cloud providers' infrastructure. While a distributed architecture is optional when you are running your applications on virtual machines, for containerization, it becomes a must. Because it does not make sense to put everything in one single huge supercontainer. You would lose all the benefits of containerization. In this diagram, you see an architecture example of a distributed application based on containers and container orchestration. This time, the boxes in blue and green are the container instances, which are running in a cluster managed by Kubernetes. A new term is introduced on this slide, the so-called pod. So what is a pod? A pod is a group of one or more containers. Pods are the smallest deployable unit that can be created and managed in Kubernetes. You can run multiple replicas of the pods in your cluster for scalability and high availability. And Kubernetes is taking care of the health of the pod as well as of the container which are running inside of a pod, and is probably restarting one of the containers or the whole pod once it's no longer healthy. So you see a lot of elements here for scalability and to improve the availability. In this architecture example, we have grouped the containers in natural online pods for the online processing, and natural service pods for everything which is coming through NTRX-based APIs, and the database and batch processing. Again, close to each other. Let's come to another trend in the market. This is the cloud. The adoption of the cloud is definitely increasing. According to analysts, the question is not whether customers are shifting workload to the cloud. It's more a question of when and which applications are selected for cloud migration. We see this tendency in our customer base as well. We have a lot of customers who already signed a subscription with one of the large cloud providers, and they are now having plans to move a significant portion of their mission-critical workload to the cloud. The good news is Adabas and Natural can be part of your journey to the cloud. We work closely together with experts from Amazon and Microsoft to create and test various blueprints for virtual machines and containers for ANN in the cloud. And Zvonimir will give you in his presentation afterwards a very nice insight. So he's demoing everything in the Azure cloud based on these virtual machine architectures as well as based on the container-based architectures. We believe rehosting an application without architectural changes is the fastest way to the cloud and can deliver a cloud migration over a short timeline because only the infrastructure is changing and the application stays as is. In an ideal scenario, the workload is shifted from a virtualized on-premise infrastructure to a virtualized infrastructure as a service in the cloud. Prerequisite, as said already, is that your applications can run on one of the supported operating systems, preferable Linux, and on commodity hardware, and that's x86 hardware. Let's again have a look at our virtual machine scenario. This time it's running in the cloud. All the components in red, such as the disk storage on the bottom, the hypervisor and virtual machines in the middle, and the network and the load balancer on top, they are managed by the cloud provider. Yeah? As part of his infrastructure as a service offering. The architecture, as you can see, you can compare it with the architecture of the on-premise example, stays the same. So, as I said, moving something without architectural changes to the cloud is the fastest way. And in this case, we have a container-based environment. And you see the cloud manager is not only managing the storage, the network, the load balancer, the virtual machines, but also manage the Kubernetes cluster, which is really great. And the Kubernetes implementation and the underlying cloud infrastructure, they are working hand in hand. For example, for scalability reasons. So you can have a auto-scaling in Kubernetes, which means if there are not enough pods running, Kubernetes is starting new instances of those pods. But if the underlying infrastructure does not have enough virtual machines to run these pods, the cloud infrastructure automatically starts new virtual machines, and Kubernetes is automatically deploying new pods on these new virtual machines. So you have an automatic scaling based on KPIs such as memory usage or CPU time usage. That said, I hope you enjoyed the presentation, and I'm looking forward to meet you next time in person. So bye-bye.